Hello and welcome to another dSPACE LearningBit podcast. Today we talk about field report virtual ECU creation. Software-in-the-loop testing is a major trend in the automotive industry. More and more companies want to test their code in earlier stages during development, and especially before integration on real hardware. A major challenge is establishing successful SIL processes is the availability of virtual ECUs. This is why I'm speaking with Christian Becker, Product Manager for System Desk and Virtual ECU Creation at dSPACE. Hi, Christian, and thanks for joining me today.
Hi, Mike, and thanks for your invitation.
So what are we experiencing in software-in-the-loop projects when it comes to the creation of virtual ECUs?
First of all, I have to say that most v-ecu projects are different. The software to be tested can vary from application-level C code to fully integrated ECU code, including the production basic software. It can be based on AUTOSAR or just plain C or C++ code without any standardized interfaces. It can contain legacy code, pre-compiled modules, or it can be a mix of all those, which may even be delivered by several suppliers. During the last years, we gained huge experience from multiple projects where v-ECUs had to be created and integrated into our SIL environment. Here we dealt with all different kinds of v-ECUs, for example, application level or production basic software v-ECUs, as well as adaptive AUTOSAR or pure Linux-based applications. On the one hand, our products and solutions are supporting the v-ECU creation processes. But just as important is that we consult our customers with our experience and technical expertise. In many cases, an important key for successful v-ECU projects is a common understanding and collaborative mindset between all parties. Despite of initial hurdles, our customers succeeded in creating v-ECUs after the situation was analyzed, requirements were clarified, and necessary action items were identified.
Interesting. Can you give more insight to the criteria which supports the successful creation of virtual ECUs?
Of course, let me focus on cross-compiled v-ECUs here, where the code is compiled for the simulator platform. This kind of v-ECUs is most dominant in the market and has largest benefits in terms of cost, performance, and availability. Here are some important criteria to create cross-compiled v-ECUs. First of all, the code must be compilable for the simulator platform. That means for a Windows or Linux platform. Furthermore, you have to take care about your code interfaces to the outside world of the v-ECU. These need to be adapted in a way that hardware dependencies are removed, and also variables to be connected to the environment need to be identified and passed to the simulator interface. A standard like AUTOSAR helps a lot since potential code interfaces are explicitly defined here, like the microcontroller abstraction layer. Further information can be found at our dSPACE website, which provides additional material in the support area. Shown here as examples are application notes which describe how to create code-based v-ECUs, creating v-ECUs for diagnostics, or how to integrate SPI devices into a SIL simulation.
What concrete actions shall be taken when approaching a project to create a virtual ECU for SIL simulation?
But first of all, an analysis of your available artifacts is important. Questions shall be answered such as, which code modules need to be integrated into the v-ECU? Does the creator of a v-ECU has access to the C code? Is there a picture of the architecture available? Maybe just compiling code for the x86 architecture and checking the results might help you getting a better overview here. But there are further requirements and boundary conditions which should be clarified in early project phases. What are the testing goals? How does the simulation system look like, and how shall the v-ECU communicate with environment or REST bus models? How frequent does the v-ECU need to be updated? Those and further questions will also help to make the right decisions in virtualization activities and finally to establish a running v-ecu workflow. After or during the analysis, we strongly recommend to involve the producers of the code, no matter if it's a direct colleague, another department, or an external supplier. The awareness about the virtualization goals and necessary measures is important for all parties, which are part of the delivery chain of your ECU software.
That's a great explanation, Christian. Now I'm curious, what conclusions can you draw and what advice can you give our audience?
Yeah, the main conclusion from our experience is that v-ecu creation processes must be introduced in a holistic way. Formerly, the focus was mainly on technical aspects of creating v-ecus and, of course, technical solutions, best practices, and know-how are important building blocks here. But for the successful v-ecu projects, further non-technical aspects are important as well. The communication between all parties, awareness about the goals, problems, and what needs to be done, a common understanding. Well, overall, you could say a collaborative mindset is a key. And we can support our customers in all of these aspects when it comes to the creation and integration of v-ecus and be a partner for successfully establishing sales simulation. Our customers can approach their dSPACE sales contact person or can contact us directly via v-ecu_taskforce@dspace.de.
That's awesome. Thank you, Christian, for joining me today and answering some important questions on this topic. For all of you watching, please feel free to visit our website at www.dspace.com and submit any questions or topics that interest you. Don't forget to hit that like and subscribe button below and follow us for more exciting content. Thank you and have a great day, everyone.
Have a great day. Bye-bye.
dSPACE, your partner in simulation and validation.